So a brief review of the three states of matter: solids, liquids, and gases. Solids and liquids have particles that are touchingly close, and so they are more dense than gases. In the gas state, the particles are separated by large distances. So this table is showing us some information about water. It gives us the temperature at which we might find these states. It gives us the density. So the density of gas, and this is in grams per cubic centimeter, 0.00059 grams per cubic centimeter, whereas liquid and solid are approximately 1 gram per cubic centimeter. And then we have molecular picture here. Lots of space between the particles in the gas state. In the liquid and the solid states, the particles are very close to each other. The important difference is that in the liquid, the particles are free to move and slide around, and in the solid state, they're frozen, literally frozen. They can't move relative to each other. It's that freedom of movement that is the big difference between solids and liquids. So in a liquid, the particles have enough thermal energy that they can partially overcome the attractions that are holding them together, and so they can slide around, but they don't have enough thermal energy to completely break free and get into the gas state. In a solid, the particles are locked in a position. They do vibrate, though. All matter is in motion. The only time you would have zero movement would be at 0 Kelvin, absolute zero, which is a theoretical temperature that no one has achieved yet. Any questions so far? So we know that liquids take on the shape of their containers because they can move around, and so gravity pulls them down, the particles down, and so they'll fill up the bottom of the container. Solids just retain their shape no matter what container they are in. Compressibility is also an important idea here. So if you take a liquid in like a piston assembly here, where you can move the lid and you press down on this, you can press and press and press and put lots of pressure on this, and you cannot compress the liquid because the particles are already touchingly close. There's no space to squeeze out. In a gas, though, there's a lot of empty space, and that empty space is not air. That empty space is empty. There's nothing there. And so by putting pressure on the lid, you can make the container smaller. You can push the gas particles closer together. And we studied all the relationships with that in chapter 5. When we talk about solids, we can refer to how the particles are arranged. So two broad categories would be crystalline solids and amorphous. Amorphous means without shape. The prefix a means without, and morphous refers to shape. So amorphous solids have no long-range order to their particles. They're random, just jumbled together, kind of like this picture here. A crystalline solid has a pattern to the arrangement of the particles. Here we see that they're lined up in nice lines, in layers, and there's order. It's three-dimensional order. Now, there are lots of different ways to put those particles together, but what makes it crystalline is that it has a pattern. So this is like kindergarten students sitting at their desks, which are all lined up in rows, and this is kindergarten students sitting on the rug around the teacher for story time. They just plop down randomly, okay? So we can change the state of a substance. We're familiar with ice melting. How do you get ice to melt? You heat it up. So you take a solid and you add heat to it, and you can cause it to change into a liquid. If you take that liquid, and add heat to it, you can cause it to go into the gas state. That's what happens with a pot of boiling water. You've got it changing from a liquid into a gas. We can also go the other way. We can take a gas and condense it into a liquid by cooling it off or removing heat. We can take that liquid and make it into a solid by cooling it further. As the particles slow down, they will get stuck and not be able to slide around anymore. These transitions between liquids and gases can also be induced by changes in pressure. So by putting a great deal of pressure on this gas, you can force the particles together. At some point, they will stick and become a liquid. You can cause the liquid to go into the gas state by reducing the pressure. Yeah?
When you say that, I guess the first thing that comes to mind is like airplanes. Is it like when you think that the crystals will form on the window of the airplane? Is that because of pressure or is that because it's cold?
Crystals forming on the windows of an airplane, you mean when you're up at high altitude? That would be due to cold.
Okay.
Yeah, because as you go up in elevation, it gets colder and colder.
Yeah, I wasn't sure which one it was. 'Cause
Yeah.
I never knew that they could change state or states due to pressure change. So I
Mhm.
just thought of like airplanes.
Yeah, that's an excellent thought. Yeah, question.
What about like a condensed like air can that like sprays air?
Yeah.
The can gets really cold.
Right. Yeah. So when you have a transition between liquid and gas, there's energy associated with that. And so those cans of condensed air for like cleaning your keyboard, when you spray them, the can gets cold.
Is that why the can gets cold?
That's why the can gets cold. Yeah. It's going from a liquid into the gas state, and that requires it to pull energy in from the surroundings to do that, and so that makes the can cold. Yeah. That the temperature change associated with the change in state of a gas is how compressors work for the air conditioning and for your refrigerator and freezer. They work by taking a gas, condensing it, and expanding it. Condensing and expanding. And so one part of that cycle makes it warm, and one part of the cycle makes it cold. That's why the outside of the refrigerator is warmer than the surroundings, because that's where the heat is that got pulled out of the inside. Yeah. Any other questions? I think one of the fun things about chemistry is it can explain an awful lot of stuff that happens in real life. So feel free to ask those questions. So here's a propane cylinder for your gas grill. It's called LP. LP stands for liquefied petroleum. It's mostly propane. So there's liquid in that container, and if you shake it, you can hear it slosh a little bit. But normally propane under regular pressures is a gas. It's not a liquid. By applying a great deal of pressure to this, we can cause it to become a liquid. There's some empty space here, and so some of the propane will evaporate, go into the gas state. When we open the valve here, we release the pressure and allow the propane that's in the gas state to escape. As the pressure decreases, then more of the propane will go into the gas state, and that will keep happening until this has all turned into a gas. The reason we do this to the gas is because it takes up so much less space when it's liquefied. And so if you've ever gotten one of those little helium cylinders to fill balloons for a party, and you've got this little canister with helium, and then you fill all of these balloons, it's like all of that helium was in this small canister. And so it's just much smaller, much more condensed, convenient way to transport it.